I'm going to do a couple examples of how to use the first and second derivative tests. And specifically, I'll probably be using the second derivative test for this one with trigonometric functions instead of just a polynomial. All right, so our first function that we have is sine of x plus cosine of x. That's going to be continuous as well. The sum of two continuous functions is continuous. So let's take the first and second derivative of this and see what we find. Derivative of sine is cosine, and derivative of cosine is negative sine. So we have our first derivative there. We can set that equal to 0 to find out what points we're looking for. So this will occur when sine of x is equal to cosine of x. The only places that they equal are going to be one of the 45-degree angles. Certainly in quadrant 1, they are both going to be positive, and they'll both be root 2 over 2. Also, when tangent is positive, so in quadrant 3, they'll both be negative. So this is going to occur when x equals either pi by 4 or 5 pi by 4. So these are critical values that we're going to look into. So let's perform the second derivative test on this. Let's take the second derivative, or just f double prime of x. So derivative of cosine is negative sine. Derivative of sine is cosine. Hey, we have the same thing. All right. So what do? We plug in our values here. Now, derivative of sine is cosine, but we have to keep that sign correct. Excuse me. It's a negative because it was negative sign before, not sine. All right. So let's evaluate our values at pi by 4 and 5 pi by 4. So our function, second derivative of pi by 4. Let's see if I can keep the sign straight this time. All right, so both of those are positive at pi by 4, but we have a negative for each of them. So this is going to equal negative root 2 over 2 minus root 2 over 2. And that's going to be negative. What is that? Negative root 2. So this is less than 0, which means we're looking at a maximum. Okay. Let me scroll down, and I may have to move that other one down a little bit. That's okay. Second derivative at 5 pi by 4. Now, each of these is negative here, so it becomes positive. So that's negative root 2 over 2 minus root 2 over 2. And that comes out to root 2, which is greater than 0, which makes this a minimum. So the last thing we have to do if we're looking for, say, the max and min for these, I'm not going to worry about sketching it, but we'll evaluate what these are, is taking the function and evaluating it at both. So function at pi by 4, so our original function is sine of x plus cosine of x. So this is going to be sine And that's 2 over 2 plus root 2 over 2, which is just root 2. And f at 5 pi by 4 will be negative root 2 over 2 minus root 2 over 2, which is negative root 2. So our 2 points, one a max, one a min. So our maximum that was at pi by 4 and root 2. That's our y component. Our minimum at negative root 2 over 2, excuse me, at 5 pi by 4 and negative root 2, and that shouldn't be over 2, excuse me. It should just be root 2. All right, I had that, I'm sorry. All right, well, at any rate, that's how we would solve finding a max and min at this problem. I think I'll save the other problem to the next video.